Unfortunately for many people, word problems are thought of as deceptive or used to trick the learner. But word problems are purposely written to elicit critical thinking and reasoning skills. Let's consider this scenario. While at the hardware store, Noah asked one of the clerks to cut him a length of electrical wire. When Noah went to purchase the wire, he realized that the clerk interchanged the feet with the inches that he asked for, resulting in only 5/8 of the length he originally requested. Determine the length of wire the clerk accidentally cut. There is no single way to solve word problems, but typically exercising a pragmatic and logical approach is what sharpens the process. All information needed to solve word problems will be provided. We need to carefully read what is occurring to appropriately construct a model or equation that fits the scenario. Also, drawing a picture that represents the situation helps visualize the process. Here, Noah ordered a length of wire and indicated the length to be a certain amount of feet and a certain amount of inches. We can label the feet as A and the inches as B. Therefore, the implications are he ordered A plus B length of wire. However, in this problem, there are two units of measure, feet and inches. They both tell the same thing, which is length, but are expressed differently. For example, consider this calendar. 5 weeks and 2 days is the same as 37 days. If there is more than one unit of measure used to express the same form of measure, such as weeks and days, it is best to express those values as the same units of measure when trying to determine a total outcome. So here we express everything as either feet or inches, but not both. We wait until the conclusion of our solution before eventually formalizing our measures. Since there are 12 inches in a foot, we express the length of wire as 12A plus B, and of course, this seems to make more sense. This is the original amount of wire that Noah requested. But as we carefully continue reading the problem, the clerk made the mistake of interchanging the requested feet with the requested inches, resulting in 5/8 of the length of the original request. We now have a model that expresses this scenario. From here, we simplify the equation and solve for the variables A and B. Recall that A represents the feet and B represents the inches. We have to check these amounts to see if they actually make sense. If the original length of wire is 12A plus B, then the length ordered by Noah must be 1,144 inches. And since the clerk accidentally interchanged the feet with inches, this does indeed result in 5/8 of the original length. However, we need to determine the length of wire the clerk accidentally cut, but formally express this in feet and inches. 715 inches is the same as 59 feet 7 inches. However, if we interchange these measures according to our findings, this does not equal 1,144 inches we calculated. So now we have a dilemma. There is no reason to think that when Noah ordered the wire that he would request 52 inches. 52 inches, after all, is 4 feet 4 inches. So if Noah did order 1,144 inches of wire, he would have requested 95 feet 4 inches. Even still, interchanging these measures would suggest that the clerk interpreted the 95 feet as 95 inches. Again, this is nonsensical. By now, it seems to reason that both variables A and B must be less than 12, because when the lengths are interchanged, no adjustment to the units of measure is required. We determine this by looking for a factor that is inflating the total length we based our model on. It seems as though our model produced a result that was 13 times more than was requested. Again, let's make sure everything checks out. The original request equals 88 inches. The clerk's cut equals 55 inches. So Noah originally ordered 7 feet 4 inches of wire, and the clerk accidentally cut 4 feet 7 inches of wire, which is 5/8 the length originally requested.